So welcome back to geometry. Today we will start with chapter 12, lesson 1, this chapter is related to circles. Let's start now with the first lesson, tangent lines. What is the tangent line? Look at there's a ray here, which is AB, ray AB. As you see, this line now touch a circle at a point. This line is not passing or is not passing inside a circle, or it's not outside so far from the circle. It's passing be closed to a circle. It touch it. This type of this line, we call it tangent line. A line that is intersect the circle in exactly one point, we called it tangent line. So if there's a circle like this, and the line intersect on it and passing inside a circle and cut or intersect a circle with 2 points, we didn't say that this is a tangent line. A tangent line, it must intersect a circle with 1 point only, and it must be out or closed of to the circle. This is a tangent line, and there's a point that touch out the point that is between a circle and a line, we call it point of tangency. So look at this circle here. Ray BA is a tangent ray, and a line segment BA is a tangent segment. So the tangent line is a line that intersect with the circle in exactly 1 point. This is the meaning of tangent. Now, so far we talk about many things. We talk about an arc, radius, diameter, secant, chord, and tangent. All of these properties, all of these things related to the circle. So let's see now what are the difference between them. We said, and we know before, that any circle, it has a radius, which is in the middle of the circle. It has a center. Now, a line segment that's connect between a center and the end point, one end point of a circle, we say it is a radius. And a line segment that's connect between two endpoints on a circle and passing through the center, we call it diameter. Now, there's a line that is connected, its endpoints is on a circle. Is on a circle, but this line didn't pass or didn't go through or didn't intersect the radius. We called it as a secant. So if it is any line segment, as we know, it has two endpoints. If these two endpoints on a circle and passing through a center, this is a diameter. And if it's not passing through a center, this is a secant. Now, a curve that's their end points on a secant, we called it an arc. This is arc. This is a curve. It's not a line. It's a curve. That's the two endpoints is on a circle. Now, a tangent, we say that it is a line that is come beside a circle. It touches in one point. This is a tangent. And the chord, it's a line that their endpoint is outside the circle, but it's going through the circle. The difference between it and the tangent, that the tangent, their endpoints is outside the circle, but it touch a circle in only one point. The chord, no, the chord, it's passing, it's enter inside the circle. It enter the circle, it's passing it, but their endpoints is outside the circle. The secant and the chord are approximately the same, but the secants, their endpoints is on a circle, and the chord, they are out of the circle. Is it clear?
Yes.
Yeah.
Can you explain again the difference between secant and chord?
The secant here, their endpoints is on a circle. But the chord, their endpoints is outside a circle.
Okay, teacher, thank you.
Yeah. Now, so we talked about the definition of a tangent line. Now, what is the relation between a radius and a tangent line? Now look at the first theorem of our chapter. Theorem 12.1. Yes, Hanin.
Teacher, isn't it the opposite? Isn't the chord the one with the two endpoints on the circle and the secant outside?
Did you mean that I read the opposite?
Yeah, like the chord has its endpoints inside the circle, and the secant is the chord, the one we drew as chord.
The chord. Yes, thank you. Secant. So from name, it must going on. Yeah, thank you, Hanin. So we have to say that here is a chord, and here is a secant. Okay, secants, there is, I'm sorry, the secants is the endpoint is out of the circle, but the chord, they are on a circle. Now, let's come back to our theorem here. Here now, let's see here. Now, if there's a line that is tangent to a circle, so this line will be perpendicular to the radius. So the tangent line is perpendicular to the radius, as we say in the endpoint. So if a ray AB is tangent to a circle with a center O at point B, so if there's a line that is tangent to a circle, so this line segment or this ray AB is perpendicular to the radius OP. So if there's AB, that is a tangent line. So, and there's a radius. So if the tangent line intersect with a circle at point P, so I will say that the radius is perpendicular to the tangent line. This is our theorem, the first theorem. If there's a tangent line, this will be perpendicular on a radius. Let's start now with the first problem here that's related to our theorem. Here now we have a circle with a center O, and now we have two tangent lines. This is the first tangent line. And this is the second tangent line. The first tangent line, let's name it with ML, it's touch a circle at point L, point of tangency L. And MN, it's touch a circle at point N. So ML and MN are a tangent to a circle with a center O. I want now to find the measure of the angle X. Now look at this shape here. Is it a triangle or is it a polygon, or what is this shape? Look at OLMN.
It's a kite.
It's a kite.
Yeah, it's a
I
kite.
think if we cut it in OM, it will be triangle.
No, but I'm talking about OLMN.
No,
It's a
it's
kite.
not.
Okay, so it is an quadrilateral. Now, what is the measurement of the angles in the sides from, or any side, any shape from four sides?
No, it's
360.
angle OLM is 90.
So, but for the angles in a shape of OLMN, the summation of the angles is 360. So what does it mean? That means angle O plus angle L plus angle M plus angle N. The measurement of them is 360. So let's say now the measurement of angle O plus measurement of angle L plus the measurement of angle M plus the measurement of angle N is 360. What I wrote this, since I need to find an angle, so I want to think about the measurement of the angles, the summation of them. This is the first step. Now, let's come back here. Now, what is the measurement of an angle O?
117.
117.
70.
Now, look at angle L. Now, in Theorem 12.1, we say that if there's a tangent line and if there's a line that's closed or that intersect with a circle, it will be perpendicular with the radius. Since it is perpendicular, that means this angle is 90. And here we have the same. This is the tangent line. It is perpendicular on a circle, so we have it as 90. So it can help me that angle L is 90 and angle N is also 90. But angle M, it's unknown. I want to find it. They are 360 degrees. Then 180 and 180 minus 117. So we have to say that X, or angle X, sorry, it will be 63 degrees. So the measurement of angle X here is 63 degrees. Is it clear?
Yeah.
Yes.
Let's have another here now. ED, or the line segment ED, is tangent to a circle with a center O. So since it is a tangent, So that's mean and ED is perpendicular to a radius. Now then, what is the value of x? Now look at the shape of DE or EDB as an example. This one here, DEB. What is the type of this shape?
Triangle.
Triangle. Right
Since
triangle.
it's a triangle, so what is the measurement of the angles inside a triangle?
180.
180.
Bravo. So that's mean the measurement of angle D plus the measurement of angle E plus the measurement of angle B is 180. What is the measurement of angle D since the radius is perpendicular on the tangent line?
90.
It is 90.
20.
And the measurement of angle E,
38.
EE, it is X.
X.
And B, it is 38.
38.
Now, as we know before, we can add them like X plus 90 plus 38
128.
equal 180, then minus 128 minus 128 here. So X is
52.
.52 This is now the measurement of angle X. Is it clear?
Yes.
Yes.
Now, this is number 8 in your problem solving questions. Lines that appear to be tangent are tangent to circle. O is a center of each circle. What is the value of X? Here we have to find angle X. And they told me that this number now with A, B, C, and O. Now look at triangle OAC. In this triangle here, OAC, they told me that this angle here is 60. And if you look at the big triangle, which is OBA, they asked me now to find X. Even know that here is, we can say, sorry, this is C, and this angle here is 60. So now I need to find X. How?
We know that angle OAB is 90, and then we can use the exterior angle theorem to find angle AB, and then we'll find A because they add up to 180.
Thank you. So the first step, so here, AB is tangent to a circle with a radius O. So it is perpendicular to a radius OA. So that's mean the angle here is 90 degrees. So measurement of the angle OAB is 90. This OAB, we can say that it is OAC and CAB. When you're adding them, you get 90. So OAC is 60 and CAB is nothing, يعني it's unknown. Sorry. So we can say that the measurement of the angle CAB is 30 degrees. So this is one here, 30. So this one here is 30. Now, this is for this angle.
Teacher,
Yes, Hanin.
the triangle OAC is an equilateral triangle, right?
Yeah. So this is the second idea here. If you look at OA and OC, are they radius? OA and OC, are they radius?
Yeah.
They are isosceles, yeah.
Yeah, they are radius. Now that's mean if you look here at this triangle, if you take it out, here we have A, here we have C, and here we have O, and here is 60. Now since OA and OC are two radiuses here, so that's mean,
Teacher,
yes, Rose,
teacher, since it's a right triangle, why did you cut it into half?
this is not cut, this is from the question.
Oh, the question say it's not.
Yeah. Then here, so OA and OC are a radius. So that's mean this is, if this the angle of the base here is 60, so this angle it will be 62. And if this is 60 and this is 60, this angle it will be also 60. I'll repeat. Now, since OA and OC are radius, or radius as we can say, so that's mean they are equal. Since they are equal, so which type of triangle did we have?
Equilateral.
Equilateral triangle.
Equilateral.
So since because of that, these two angles are equal. So if this is 60, this will be 60. And the measurement or the summation of the angles inside a triangle is a 180. So if the bases here are 120, so what is the measurement of the third angle will be?
Also 60.
Also 60. Is it clear?
Yes.
Yes.
Okay.
Yeah.
Teacher, you mean like the angles are equal because they are equilateral?
Yes, since the radiuses here, the OA and OC are a radius, so they have the same dimension. So we can say that I have here 60 and here is 60 and here it will be also 60. So now I found that is 60, this is 30. Now I need to find angle X.
So 60 plus 90 plus angle B
Bravo.
equal 180.
Yeah, now look at the big triangle here. In the big triangle, we have here is 90, here is 60, which is O, and B here, it is X. Now I'm looking at this one here. I'm looking at this big triangle. So angle A is 90, angle O is 60. I need to find angle X. How? By using the summation of the angles in a triangle, that measurement of angle A plus the measurement of angle O plus the measurement of angle B is 180. So 90 plus 60 plus measurement of B, or because so which is x is 180. So 100, so angle x will be
30.
30 degree.
30.
Is it clear?
Teacher, the whole triangle angle sum is 360 or also 180, like the
No,
right triangle?
any triangle 180.
Okay, thank you.
You're welcome. If the side is from the shape from three sides 180, from four sides and above 360. And if it is only one line, it is 180 also. This is for the line segment.
Okay, teacher, thank you.
You're welcome.
Teacher, what was the answer?
30. It was 30, I think, yeah. No. Here in this problem here now, the CN Tower in Toronto, Canada has an observation deck 447 meters above ground level. So here we have an earth, as you see, above the earth with 447 meters, we have a tower. Now about how far is it from the observation deck to the horizon? Earth radius is about 6,400 kilometers. Now let's look here. Here now there's an imagine now there's a one here, there's observation at point A. And they told me now what is there's a man like it is here. Okay, they look at the top of the tower. Now and we know that all the things, or what did you know? We know that the length of the tower is 447, and this is, I imagine that is the center of a circle. The radius of the circle now here, of the radius of an earth is 6,400, 6,400. This is the radius of a circle. Now I need the distance from this man at point E up to the tower at point T. Now, how did we solve it? If we know the distance, or if we have like a line, and I mean like when you are in a grade 8 as an example, when you have some questions like this, when I told you now you are on the King Abdullah Street as an example, and here you have an Kingdom Tower, and you are here, and you want to find the distance from you to the this tower. You told me, teacher, since the angle that's I'm looking to the tower here is 45 degrees as an example, and I know that the highest of the Kingdom Tower is, or the length of the as an example 4 kilometers. Then I'm asking you about the distance between you and the Kingdom Tower. You will tell me, teacher, I know that this is 45, this is 4, and I need to find this side. So you have to say that I can use tan 45, which is the opposite over an adjacent. Then after that you will find that this is 4. If you are on a street, if you are on a straight line. But in this problem here, if you are in a circle, so we cannot use tan or sine or cosine because I want to find this one, but here I don't have a line or a straight line. I will use now, I will say that since I am on a circle, I am on an earth, and my line from E to T is tangent to an earth at point E, so I can use a theorem 12.1 that we say on it, if there's a line ET that is perpendicular on a radius AC, so this is a right triangle. Since this is a right triangle, this is E, this is C, and this is T. Now, since this is a right triangle, so measurement of the angle E is 90. Okay, now I am not talking about the angles. I am not asking you about the angles. I'm asking you about the dimensions. If EC is 6,400 degrees, and if C up to the earth, now don't forget that you are on earth. So that's mean you are here. So that I told you now the radius of a circle is also here 6,400. And from the earth up to the tower, it is 447 meters. Then I want to add them since they are not with the same unit. So you have to make or to convert a meter to kilometer by dividing on 1,000. So it will be 0.447, or here write it as 0.45. So now this is 0.45 kilometer. What's the time now? Is the period finished?
It's 11:25.
Oh, it's finished.
We still have 4 minutes.
Yeah.
No, it's 25.
No, I'm looking at the Zoom meeting. It says the meeting will end in 4 minutes.
No, this is because I'm being. So, okay, I will continue this one now.
So
So here we have 6,400. Here we have 6,400 plus 0.45. So now the big triangle will be 6,400, and this one here, it will be 6,400 plus 0.45. Okay, I need now to find this one, which is ET. Do you know why they are 6,400.45?
Yes, teacher.
Yeah.
Then after that, now adding them because I want to find the big triangle. Now after that, this number, which is 6,400.45 squared, using the Pythagorean theorem, equals TE squared plus 6,400. So ET squared plus 6,400 squared will be, then you will continue, you will find that ET, your distance from you up to the top of the tower is 76 meters.
But teacher, in the quiz, you're going to draw it for us, right? Like we're not the one who will draw it.
Yes, inshallah. Okay, here inshallah tomorrow. Oh no, sorry. In the next period, we will talk about these questions here. Okay, you will see now. I will repeat for you how did we solve it. Thank you.
Okay, teacher. Thank you so much.